Now it's time to derive the formula for the sum of a geometric series with first term a, common ratio r, and n terms. Now if you saw the previous video where we used some numbers, the approach is going to be the exact same here. The only difference is we're going to be using letters. So let's begin. Over here, we have a very general geometric series that goes a plus ar plus ar squared all the way to plus a times r to the n minus 1. And we're going to be doing the exact same thing. So to find the sum, let's denote it as s. And if you saw the previous video, we always introduced a new series. But how did we determine this new series? Well, we would do that by multiplying the original series by the common ratio. So it would be r times s. That would be our new series, because then we would be multiplying each term in our initial series by r. So a times r, that gives ar. Ar times r, well, that's ar squared. And we would get this all over again. We've seen this before. It would just continue until the final term, a times r to the n minus 1 times r, is a times r to the n power. And from here, we would always notice that every term in the middle would go away if we simply subtracted the two series. So we would get s minus rs equals a minus a times r to the nth, because everything in the middle disappears. And from here, we can factor like this on both sides. And of course, since we want to find s, we can divide both sides by 1 minus r to get this formula that many people are very familiar with, but very few understand where it actually comes from. But now you do, because you just saw the whole process. And it should be noted that there is one condition. Since we are not allowed to divide by 0, of course, the common ratio cannot equal 1. So now we really understand where the formula for the sum of a geometric series comes from. So if we ever forget, we can always do it again.